Okay, guys, I wasn't getting a whole lot of questions from people off the Chapter 8 review, which scares me a little bit because we're taking that test here very soon. And remember, guys, the test is going to look just like the review, but somebody did ask a couple, so I thought I would go through number 8 and number 11 with you. Now, number 8, the directions here are just to find the missing sides, which are X and Y. So one of the things I want you guys to be able to recognize is which method it is that we're going to use in order to solve a triangle. Now, in this one, the Pythagorean theorem doesn't work because we only were given one side of the triangle. For the Pythagorean theorem to work, you'd have to know two of them and try to find the third. And basic trigonometry, sine, cosine, and tangent could work here, but really, because this is a special right triangle with a 60-degree angle and a 90-degree angle, that means that this one up here is a 30-degree angle. That means that we can do this one without using our calculator and without using trig if we have our basic patterns of a 30, 60, 90 memorized. So we want to remember that in a 30, 60, 90 right triangle, your side lengths are going to be, the short leg is x, the long leg is x multiplied by the square root of 3, and the hypotenuse is 2x. Now normally, if we were in school, I would tell you guys that's something you need to have memorized. For now, you just want to make sure that you have that available to you somewhere, and your notes are on your homework when we take the test here in a little bit. So the important thing to recognize is that the side we know, the only side we know, the 4 root 3, is your hypotenuse. And lately I've been boxing that up a little bit, and we want to come up with the two legs. Now the key to a 30, 60, 90 is the short leg. If you don't know that already, you want to find that one first. So let's figure out how we can find y. So to go from short leg to hypotenuse in a 30, 60, 90, we always multiply by 2. We need to go backwards right here. So we're going to take our hypotenuse, which has a length of 4 times the square root of 3, and we want to divide that by 2. Now again, the newer Texas Instruments calculators will handle this for you. If you just type in 4 root 3 divided by 2, it'll give you the answer. But for those of us doing this by hand, I want you just to realize that there's a common factor of 2 here in the 4 on the top and the 2 on the bottom. So we just divide a 2 out. 4 divided by 2 is 2. The root 3 goes along for the ride, and the 2 on the bottom, when you divide a 2 out, just leaves you with a 1, and we never need to write a 1 on the bottom of a fraction. So 2 root 3 is the value of y. That is your short leg. Now let me switch colors on you here, and to go from short leg right over here to the long leg, all we need to do is take whatever our short leg is and multiply it by the square root of 3. So to get x, we start with y, which is our short leg, 2 times the square root of 3, and we always multiply whatever that number is by the square root of 3. And in this case, there's some simplification that can be done right here. Root 3 times root 3 just equals 3. So this becomes 2 times 3, and we end up then with x equals 6 for that answer there. And here we go. X was 6, and y was 2 root 3. Don't be fooled by the alphabetical order of the variables here, guys. It doesn't necessarily mean that you have to find x first before y. The short leg is the key right here in a 30, 60, 90. So if you don't know the length of your short leg, but you do know one of the other sides, you always want to find that first. And the other question I was kind of asked was problem number 11 here. So we're supposed to find a missing side and round to the nearest tenth. All right, so let's take a look at what we know. Again, the Pythagorean theorem wouldn't help us here because we only know one side length. For Pythagorean theorem, you would need to know 2. And this triangle here, even though it looks a lot like it, this is not a special right triangle. The only 2 specials we know are 30, 60, 90 and 45, 45, 90. And the presence of that 65-degree angle doesn't fit with either one of those. So that means that we're going to have to use some basic trig, sine, cosine, or tangent. So SOHCAHTOA is what you guys want to be thinking about on a problem like this. Which of the 3 trig ratios is going to help us solve for x? So you are going to be standing right here at the 65-degree angle. Looks like your head has separated from your body. You might want to get that looked at by a doctor. Anyway, let's take a look at what's going on. X is the side that we want to know. 19 is the side that we do know. Now here's your right angle, which means that this side over here is your hypotenuse. We don't know the hypotenuse, and we're not being asked to find the hypotenuse. So that tells you something right there. The 19 is the leg that's across the triangle from you. So that is your opposite leg. And the x is the leg of the triangle right next to you. So that is your adjacent leg. So we're looking for the one trig ratio that uses opposite leg and adjacent leg, opposite and adjacent. This is a tangent problem. So we write tangent, and we always follow a sine, cosine, or tangent with the angle. We know that our angle here is 65 degrees, so we'll run with that. And tangent of 65 equals, and the fraction we're dealing with now, opposite leg over adjacent leg, that's the definition of tangent. Opposite leg is 19, and adjacent leg is x. Now this is not our favorite setup because the variable is located on the bottom of that fraction. So what we do in a case like this is we take the left side and the bottom right and we just flip-flop these two. So our new equation now is going to put x by itself on the left is equal to the 19 does not move. That stays on the top of the fraction on the right, but the tangent 65 degrees now becomes the denominator on the right. And that's a big expression we can put in our calculators right now. So let me grab, let's see here. We'll go back to the same calculator we were using before, which is this one here. All right, and we were typing in 19 over the tangent of 65 degrees. So I'm going to hit 19, my fraction button, and then down in the denominator, tangent of 65 gets us an answer of 8 point blah, blah, blah. Our directions here said round to the nearest tenth. So the 8 is in the tenths place. I look at the 5 that comes after it. That means I round that 8 up. So this is going to be 8.9 for our value here for x. Now the one thing I want to do to kind of check this answer before I box it up, the only thing we knew here is that this leg right there had a length of 19, and that's across from a 65 degree angle. That's the larger acute angle. This one down here then is the smaller acute angle, which means that x has to be the shorter leg. So I knew my value for x had to be less than 19, and I certainly could have assumed that by looking at the diagram, assuming that it was drawn correctly, and I feel pretty good about that one. While I have you guys here, I didn't do this one just yet, but let me do one of these next problems with you. Let's take a look at problem number 13. And I'll just go ahead and draw this one out. 13 is asking you to find the measure of an indicated angle to the nearest degree. So they've given you a right triangle, kind of drawn something like this. Here's a right angle. We've got a 28 for this leg up on top, a 42 here for the hypotenuse, and we're looking for this angle. And again, they gave you a question mark. We're going to go ahead and put an X right there. So we're supposed to come up with the measure of that angle. Okay, so when we're looking for a missing angle, it's again a question of either sine or cosine or tangent. So we better figure out which sides we're dealing with right here. Well, you are going to be standing right here at the angle in question. The 42 is across from the right angle. So regardless of where you are, this side right here is going to be your hypotenuse. And the 28 is all the way across the figure from you. So 28 now becomes your opposite leg. So that means we need the one trig ratio that deals with hypotenuse and opposite leg. That is going to be sine. So we write sine, we always follow it up with our angle. This time we don't know what the angle is, so we'll put an x there. So sine of x is equal to, leave yourself some space now, and then we'll put our fraction for our ratio here. And sine is the ratio of opposite leg over hypotenuse. Our opposite leg is 28, and our hypotenuse is 42. Okay, now the one interesting part right here, guys. You find your variable, which is right here, that's x. They are taking the sine of it. So we need to undo that sine with its inverse operation, which is brilliantly titled inverse sine. So we'll take the inverse sine of the left side, and we'll balance that out by also taking the inverse sine of the right side. The inverse sine and sine are going to completely cancel each other out. Sorry, guys. And what are we left with? We have an x on the left, and on the right, we're going to do the inverse sine of 28 over 42. So it's a little goofy on this calculator. I got to hit this function button, inverse sign, and here we go, 28. And again, guys, you can use your fraction key here, or you can just do the division key. It works the same either way on this calculator. And I ended up with 41.8. Now, reading my directions, it says find the measure of the indicated angle to the nearest degree. So that is going to round to 42 degrees. Okay, so x is 42. We were talking about an angle measure here, so I'll put that degree sign there, and there we go. So that's how we do a problem like that. Okay, guys, keep plugging away at the rest of this review, and hey, if it were me, I would have this review right next to me as I was working on the test, because they're going to look very, very similar. Good luck.